In this video, we're going to begin to look at how we take solutions and we can dilute them to a lower concentration. Now, this is something that happens all the time. It happens for me quite frequently. It's a real-world problem. There will be times when I'm preparing for a lab and I'll need a specific amount of a particular concentration of acid. 1 molar hydrochloric acid is something that we use pretty frequently in lab. And usually I'll need a certain amount to make sure that I have enough for all of my classes. And when I go back to the stock room with all my bottles of stuff, I only have 12 molar hydrochloric acid. The reason for this is that 12 molar hydrochloric acid is the most concentrated hydrochloric acid that we can buy. And to buy 1 molar hydrochloric acid would be much more expensive. So I can take the 12 molar hydrochloric acid and very cost effectively dilute it and use it instead of purchasing already made 1 molar hydrochloric acid. It's kind of like buying more concentrated laundry detergent so that you don't have to buy the giant bottles of laundry detergent. So now I have to figure out how to make the solution that I need. I'm going to take some of the 12 molar hydrochloric acid and I'm going to dilute it with water. Now remember, we always add acid to water. So I want to add acid to enough water to make it up to 1 molar. So what I need to figure out is how much to dilute. So I need to know how many moles I'm going to end up with of the hydrochloric acid in my dilute solution. And we know that our equation for molarity is molarity equals moles over liter. So for my dilute solution, molarity of dilute equals moles of dilute over liters of dilute. And if I rearrange that just for moles, then I know that my moles of dilute are going to equal my molarity of dilute times my liters of dilute solution. So now I need to figure out where these moles of HCl are going to come from. Well, if I'm diluting the more concentrated solution, the moles of HCl in my dilute solution are going to come from, hopefully, just the HCl, the concentrated solution. They're not going to come from the water, and those are the only two things that we're putting together. So the moles of the concentrated solution will be equal to the moles of the diluted solution. So now I have to figure out what volume of solution I'm going to need to get that number of moles. So I know that for my concentrated solution, my molarity of my concentrated solution is equal to the moles of the concentrated solution divided by the liters of the concentrated solution. And if I rearrange that to get the liters by itself, I know that my moles of concentrated solution divided by my molarity of my concentrated solution will give me the volume of that concentrated solution that I need. So let's take the last slide and this slide, those two equations, and put them together so that we can figure out exactly what to do. And it'll end up being very simple. So we know from the last slide that our liters of concentrated solution equal the moles of the concentrated solution divided by the molarity of the concentrated solution. And since the moles of the concentrated solution are equal to the moles of the dilute solution, that was in the slide before that one, and the moles of the dilute solution are equal to the molarity of the dilute solution times the liters of the dilute solution, we can take that and we know that the moles of the concentrate are equal to the moles of the dilute. So we could substitute in moles dilute here, but let's go ahead and take it one more step. We know the moles of the dilute are equal to the molarity of the dilute times the liter of the dilute. So we're going to come in here and substitute that in for our moles of our concentrated solution. So when we do that, we get our liters of concentrated solution is equal to this molarity of dilute times liters of dilute divided by our molarity of our concentrated solution. And we can quickly rearrange that to make it look a little neater. That gives us our liters of concentrated solution equal to molarity of dilute times liters of dilute divided by our molarity of our concentrated solution. Or more simply, M1V1 equals M2V2. Now, this is an equation that is available in your reference table, and you may find yourself wondering why I'm going through all these steps to try to figure out an equation that you can easily look up on your reference table. But it's important because you need to understand where these equations come from. This is all very basic algebra, and hopefully you are seeing where it comes from so that you understand why we're using this equation. It is in your reference table on the formulas page, and we will be using it for all of the dilutions that we do. Let's try a practice problem. Take a minute and pause and read the problem. The problem is asking what volume of 12 molar hydrochloric acid is needed to make 500 milliliters of 1 molar HCl solution. So that was our original problem that we talked about. First, we need to recognize that this is a dilution problem. We're making a less concentrated solution of hydrochloric acid. We need to focus on the fact that we're changing the concentration of our solution, not that we have a calculation that has two concentrations in a volume, because what will happen as we move forward and we get to Unit 9, which is stoichiometry, you'll find that that'll create a problem because you will have other problems with the same information that are not dilution problems. Now, the next thing we need to look at is we have our dilution equation, M1 V1 equals M2 V2. We need to figure out how to pair the molarity and the volume for both sides of the equation. So we need to be very careful. That's the difficult part of these problems. It doesn't matter which molarity and volume are 1 or 2, but we need to pair them correctly and be consistent through the problem. So let's read the problem. It's telling us that we need to make 500 milliliters of a 1.0 molar hydrochloric acid solution. That tells me that those two belong together, the 500 milliliters and the 1.0 molar. So let's go ahead and pair those. It doesn't matter whether we call them M1V1 or M2V2. We just need to pick and choose. So let's call the 500 milliliters V1, and we'll call the 1.0 molar M1 because those two belong together. Now let's look at the rest of the information in the problem. We have a molarity, and we're being asked for a volume, so we need to call this M2, and this volume, the one that we're trying to find, will be V2. So what we can do now, we need to solve our problem algebraically so that we can just go ahead and plug in our numbers and solve for the answer. So let's get V2 by itself. So we're going to divide both sides by M2, and you'll see that these will cancel out. And so I'm going to just switch sides here. V2 equals M1 V1 divided by M2. And then I can go ahead and plug in the numbers that I have already assigned to my variables. So M1 we said was 1.0 molar. And V1 is 500 milliliters. That's a decimal. And then I need to divide by M2, which is 12.0 molar. Now, I know that some of you are looking at this problem and going, now wait a minute, this is a problem that is molarity. Shouldn't we convert that unit of volume, milliliters, to liters? You may do that, but you do not have to. If you notice, our molarity here will cancel, and it will leave us with milliliters, which is a unit of volume. My problem doesn't specify what volume unit that I need to use. And so I can go ahead and just leave it in milliliters, and that will be fine. And you can actually do that with any volume unit. Now, there will be times when you do have to convert them. We'll go through an example. But for this problem, go ahead and punch it into your calculator, pause and punch it in. And you should get 42 milliliters, 2 sig figs, in our answer. Now let's try another problem. Go ahead and pause and read the question carefully and think about how to correctly pair these. in this problem, it's giving me roughly 750 milliliters of 12 molar hydrochloric acid. So it says 12, first of all I want to ask, is it a dilution question? You want to look, we've been given 12 molar hydrochloric acid and we're making 6 molar hydrochloric acid. So it's being diluted, a more concentrated solution being made into a less concentrated solution. So this is a dilution problem. So let's look at how to set this up. We know it's going to be M1V1 equals M2 V2. We know that we have 750 milliliters of 12 molar hydrochloric acid. So this is going to be my M1, and this is going to be my V1, because those belong together. And it doesn't matter if you want to call them M2, V2, that's fine. Now, since I've called those ones M1 and V1, this concentration is going to be my M2, and the how much is the volume question. So V2 is what I'm going to be looking for. So I'm going to go ahead and solve algebraically to get V2 by itself. And I'm just going to switch sides here. We know that M2 is going to cancel out. V2 will be M1 V1 divided by M2. And then I can just go ahead and substitute in my problem the numbers that I have from my word problem. So here I have 12.0 molar, and I have 750 milliliters, and then I'm dividing by 6.0 molar. And again, my molarities cancel. They leave me with a unit of milliliters. And when I do my math, I find that I can make 1,500 milliliters of solution. 2 sig figs in my answer.